Well, my name's Aaron Magnan. You might know me. I make some of the YouTube videos that you see. I've done some other webinars in the past related to Fusion 360 design uses. But today I have a special guest with me, Brenton Alexander. He's going to be showing us how we can drive designs from calculations using Swift Calcs and Fusion 360. So Brenton and his team have developed an amazing tool that's going to help you design some very complex things and leverage some complex mathematics while you're at it. So before I pass over to Brenton, I wanted to do a quick, what is Fusion 360 for those of you who might not be that familiar with it. Fusion 360 is a 3D CAD, CAM, and CAE tool. It's all three of those things. So a lot of people are probably using it right now for CAD. A lot of people are probably using it for CAM. But in addition to that, you can do things like create renderings and so on and so forth. I actually meant to allow Brenton to introduce himself at some point in there, but I totally skipped over that. So I'm gonna pass it over to you real quick.
Sure. So thanks for having me. I'm Brenton Alexander, founder and creator of Swift Calcs. I'm a mechanical engineer by background. Spent a number of years as a thermochemist and an electrochemist. Both in the academic realm and in the professional realm, and came to create Swift Calcs from my experiences as an engineer, working as an engineer, and some of the problems I was having in engineering. So basically, in the computational space, the tools have not evolved in the same way that they have in the CAD space. So if you look at CAD today versus what it looked like in the 80s, the tools are vastly different. But if you look at the computational space, they look almost the same today as they did in 1987. So spreadsheets, they look and work the same today. Other script-based computational tools, they look the same as they did 30 years ago. Swift Calcs was designed to make computation a lot easier and more straightforward for engineers working in the space. So no more spreadsheets with really hard to find calculations that are really hard to decipher. No more having to learn computer code or special scripting languages to get the work that we needed to do done. In Swift Calcs, the idea is that what you see is what you get. So equations look formatted as they would in a textbook, as they would on paper, very visual to understand and very intuitive to enter and answer your equations without needing to learn a whole new programming language. Computations that are dynamic. So instead of code where you change things, you have to save, then you have to rerun it to get your answers. In Swift Calcs, you make a change, everything automatically recalculates and recomputes in real time. A solution that is smart and eager to help. So there's a whole lot of data out there that's already available. Why do we have to go to Google to find the modulus of titanium when we want to do a calculation in a spreadsheet, for example? Our tools should know what we need internally. So in Swift Calcs, we're unit enabled. So you can do unit-based calculations with a variety of units from meters to light years to amps to volts. You name it, we have the unit, including currency and currency conversions. We have a built-in material library of thousands of different materials with modulus, failure modulus. We also have a thermodynamic library of a bunch of different species that's based on the NASA Glenn database. So you can build mixtures and find enthalpies and entropies of different mixtures. The idea is to have a calculation suite built for engineers that's intuitive and easy to use without having to dig into it, thousands of different tools across Fortran and all kinds of crazy old code bases. And then we're trying to take advantage of the best of 21st century computational power. So everything's in the cloud with Swift Calcs. Instead of having to download and install software and then worry about software versions and whether the people that you're sending documents to have the software, at Swift Calcs, it's all through your browser. It's all in the cloud. You can access from any device. You can share with anyone in the world instantly, just with the click of a button inside the application. And with our plugin for Fusion, for example, that means documents that are attached to a Fusion document go with the Fusion document. So if you save your Fusion file, share it with somebody else, when they install the Swift Calcs add-in and open it up, they'll have the Swift Calcs documents attached to that file ready to go in their browser as well. So that's my background. That's Swift Calcs.
Beautiful. I love that first slide. I can't believe that Excel looks exactly the same. First of all, I want to show you where to go to get Swift Calcs. So if you haven't been using add-ins for Fusion 360 yet, the way you're going to go and find it is the add-ins drop-down. If you select that, it'll take you to the Fusion App Store. This will open up a new tab on whatever browser you're working on, and here you can see there's a full list of different apps available at this time. What it does is it creates a link, essentially, between your Fusion designs and these calculations that you're able to drive your designs with. So if I use the drop-down under Modify, you'll see a couple of options that are tied to the Swift Calcs tool. It's this Load Swift Calcs and this Sync Parameters with Swift Calcs. So what I'm going to do is I'm going to select the Load Swift Calcs. And we're going to drive the design that you see there from a document. And login for this is simple. You can use, a Google login, your LinkedIn login. I'm going to just use my email login. Here you can see it takes me to the location where this SnapFit document is actually located. So I'm going to click to open it. And you can see it's got all this information about how SnapFits are designed and how to get the proper geometry and to enable them to open and close with the right force requirements, essentially. So some things I want to point your attention to are things like the unit systems that you see here. This document I'm not going to take credit for. This is actually an example document that's included with your Swift Calcs. So I'm going to show you where to go and find some of these powerful examples here. Under the Help dropdown, you're going to see some example worksheets. If you click that, you can see some simple ones, some of the more complex ones. This one's really neat. It actually pulls data from a CSV, so you can actually compare data and do all kinds of crazy stuff. So essentially, what's going on here is this whole document is speaking about how you should design these snap fits, and you can see it has sliders to help drive the design. It's describing each one of these dimensions and angles and things like that. But essentially, what it's doing is it's trying to figure out how to properly design these things for the force requirements. So at the bottom here, I want to actually now link what we've figured out from this SwiftCalc document and push it into Fusion 360. So at this point, I'm going to use the dropdown here. I'm going to say to create a new user parameter. So there's basically 3 dimensions I want to drive on the snapfit that I've designed. And so I'm going to just give it a name related to that. So I'm going to just say L length. We'll just spell right. I'm going to type in length. Click OK. And so now this length parameter that I'm creating to access inside of Fusion 360, I'm going to set equal to something that's already in this document, this L value here. So here you can see the L value in my list of inputs. So whatever that value will be, it's going to actually take that and transform it into Fusion 360. So I'll click enter, and I'm going to select to sync to Fusion 360. And at this point, if I jump into Fusion 360, I get this window telling me just that. It's telling me the parameter has updated from SwiftCalcs. If I click OK and go and look at under Modify, I'll see this ability to change or access the parameters that we're looking at here. And that value that you saw in the slider, that 7.8 millimeters is represented there. It actually is nice enough to tell us where this parameter came from. So this created and shows me in the comments created and managed by SwiftCalcs. And so now I can actually access and use this. So maybe I'll jump into this value that you see here. Sorry, this sketch that you see here. Double click on this dimension. Instead of being 50 millimeters, I want to set it equal to the length that we got from SwiftCalc. So I'll hit enter, and that changes my geometry. And so obviously this the rest of the scaling on this sketch are not really related to this. So I'll make a couple other changes there in just a moment here. There we go. Make it a little bit more appropriately sized. But the next thing I want to do is I want to adjust the thickness of this guy here. So in this case, I want to actually create a parameter within Fusion 360. I'll just select to add a new parameter. We'll call it thickness. And I'll type in a value for now. I'll make it 10 millimeters and click OK. And then we'll double click on this and we'll set this to that thickness parameter. Now the neat thing is that this is bi-directional, and all I need to do in order to be able to access and use and recall this information from SwiftCalcs is to jump into my Modify dropdown once again and sync those parameters. When I do so, I'll go and I'll reopen this Swift Calcs document that this document is actually referencing. I should have the ability to recall what I just created there. So at the bottom here, we'll go back to this area where I'm actually syncing these parameters from Swift Calcs to Fusion 360 and so on. I'll select to add another parameter here. Use the drop down there. There's that thickness we just created. So I'll set that equal to another parameter that's in this document already. I think with that, I'll pass it over to you, and you can get into some additional examples.
Sounds good. So hopefully we're all looking at my screen now.
Yep, I'm seeing your screen.
Cool. So I'm going to start showing a few of the more advanced examples of Swift Calcs here using this reciprocating saw model, which the folks here at Autodesk were kind enough to produce for us. So this is a great example of why Swift Calcs may be useful for calculations to drive parameters. Oftentimes when we're designing a product, the dimension of a parameter, the dimension of a part in a product, that may be the output from a calculation. So as I said before, my background is in thermochemistry, electrochemistry. A lot of times when I was doing heat and mass transfer calculations, a diameter of a pipe, for example, that would be the output from a heat transfer calculation, where our inputs would be things like temperatures and heat fluxes in watts and things like that. So in this example, what we're looking at is a reciprocating saw. We have a motor here that turns. It drives a larger gear, which then turns. As it turns, it drives the reciprocating saw blade back and forth. The radius at which this arm attaches to this gear is important for determining how much power is going to go into the blade versus how fast that blade is going to cut. So we want to optimize that attachment point. And so what we've done is created a sample document, which I already have open here, for the design of this reciprocating saw. And so as Aaron showed a little bit of, Swift Calcs worksheets, they allow you to integrate all kinds of different media into a single worksheet to help create very readable and visual calculations. So here we have some text at the top. The text is what you'd expect from a normal text editor. You can control things like bold, italic, underline, change sizing, change colors, anything you do in any rich text editor to create text you may need to help explain your calculation. We've dropped in a picture here just to help elucidate what's going on with this calculation. And then at the top, we start getting into the calculation itself. So what we're trying to say is for a normal user, who we're calling 180 pounds, which is the average American, both male and female, where they put roughly 30% of their weight into the saw when they're making a cut, how do we optimize that attachment point to get the fastest cut rate for that saw itself? So as we go through, we start defining our motor parameters. And again, we can use all kinds of units in Swift Calcs. So we have pounds for the user. The torque at our stall point is in Newton meters. We then can define functions. So the angular speed of this motor is related to the torque. So we're defining essentially the motor curve here. Our gear parameters, the radius of those two drive gears are defined. We define pieces of the saw, the kerf, the pitch, the blade thickness. And then we start getting into some regression analysis. So how fast does that saw cut through materials? The feed rate is actually fairly complicated. You could probably spend an entire doctoral thesis trying to describe this process. But you can pull some data that helps correlate the pitch rate with the feed rate for a particular saw blade. So we've done that here. Taken this data, we've run a regression, an exponential regression. So in Swift Calcs, we have all these tools on the left side under our toolbox. This one is actually under the data area. There's a regression fit line. We copy that in. We get the regression parameters. We give it our X and Y data. We pick the type of regression that we want to use. Here we're going to use exponential. And it'll calculate the exponential regression and turn it into a function for us that we can then utilize directly. We then plot this just to visually see that it matches the data. So you can see I have a scatter plot here with the two data sets, and then I have a function plot for this feed ratio calculation that I just did with this regression parameter. And the fit matches the data fairly well. So we relate our normal force to our cutting force just by setting them equal to each other. That's strictly not totally correct, but for the purposes of this calculation, we'll go with it. The output here is in newtons, but if I'm American and I care about things in different units, I'm going to check that over the pound force and see what that looks like. That gives me an answer that may make more sense to me. So you can change your unit answers on a per answer basis. You can also do it on a worksheet-wide basis. And so what we're doing here is we're saying, what's our cutting rate as a function of the radii of the gears, as a function of the speed of the motor, and as a function of that feed ratio. And we're trying to solve when is the change in this cutting rate as a change of our optimum radius attachment point equal to 0. And we're doing the decutting rate dr equals 0 because when the derivative of a function is 0, that's the maximum or minimum point, and here we know it's the maximum. So in Swift Calcs, we have solvers built in. Again, under solvers, we have a few different solvers here, including an ODE solver. Here we're using the generic solver. We would just drag and copy that in. Enter the equation we want to solve, enter the variable we want to solve for. Here we're going to use the numeric solver, so we give it an initial guess. For simpler calculations, there's also a symbolic solver, which will solve it directly and give you all possible solutions. And it'll solve the equation and tell us that our ideal radius here is 19.88 millimeters. And then what we've gone and done is attach this to our Fusion 360 document. So our curve, our radius of our gear, and our thickness, we've all linked to 4 different user parameters in Fusion 360. And just for fun, at the bottom, we decided to plot, what is the cutting rate versus the arm radius. And you can see our solution is right there at the maximum point. And then we've plotted that on the motor curve as well, and it should come as no surprise that our maximum cutting rate is also at the maximum power point of that motor. So right now we're coming in at 19.88 for our radius, which is what was showing up here on the Fusion model. But we can also go in and say, 180 pounds might be the average American, but the average workman out there on the job site, they might be more like, 6'2", 250. So if we update this slider to 250, calculation will automatically recalculate through. If we come through to the bottom now, our ideal radius for this user is actually smaller. It's 14.3 millimeters to give them the maximum cutting rate. So if I sync this to Fusion 360, should come in here, sync the parameter.
You can watch the model update in the background.
Model should update in the background. I'm actually already had it at that point now that I think about it. So we're going to update it the other way. We're going to put this back to 176. Now we're at 20.3. I'll go ahead and sync that through.
Or maybe it just synced so fast.
And there you could see it switch quickly in the background as they change the radius. So essentially what we can do is design models, and here we're controlling one type parameter, but you can control as many parameters as you need. You can create your model to have more than one calculation. When you open Swift Calcs from Fusion by going to Modify and then Load Swift Calcs, it'll load a project where you can have more than one calculation in it. So we have one calculation here. We could create more. For the blade kerf, we could have a different calculation. Go through and enter our mathematics here and have that also update to the model. And so we can create really complicated models with really complicated mathematics backing them. And all this then travels together. So when these models move on to different users, when they travel around the company, when you come back in 6 months and say, why is it again that we chose 14.7 millimeters for that attachment point? You can pull up your worksheets and see what your true inputs were, which were, for this calculation, what was the weight of the intended user. And so that's Swift Calcs with Fusion. It's linking your design calculations with your actual CAD geometry.
Wow, I am blown away at what you did there. I have a quick question. If you change it from the Newton-Raphson to like the direct solve, like how long of a solve time are we talking about for something like this?
So for this example, if I changed it, I think it'll give me an error because it's too complicated of an expression. So I don't know if it can calculate it directly. Okay. Actually, I lied. I changed it symbolic and it gave me the answer immediately. For a lot of equations, you can come up with pretty simple ones. So I'll put in here, if I did something like x cubed equals sine of x for x, the symbolic solver is going to yell at me there because you can't isolate x in that equation. But I can change that over to my numeric solver and it'll give me an answer If I want something that's not near zero, I can give it a different initial guess, and it'll give me the next answer, because there's obviously more than one answer to this equation. So it's, it depends on the equation you're trying to solve, what type of mode you want to use.
Does it solve these on the cloud, or is it solving it using local processor?
Yeah, so it's solved on your computer. Everything's stored in the cloud, but to keep speeds up, everything is actually calculated locally.
Okay.
So all the calculations are done on your machine. And the beauty of this is, because the software is in the cloud, as we improve the software, as we add more features, your calculations automatically get all those new features just on day one.
Yeah. Well, that is absolutely incredible. You are a very smart man.
In Swift Calcs, under the help menu, we do have a help topic section. It has a number of tutorial videos for how to use Swift Calcs, from very basics, how to use the screen, where is stuff around the screen, to more advanced topics on differential equations and things like that. And then at the end of the day, if that's not enough, support tickets, reach us directly. We try to answer within 24 hours, and we always publish our email. It's either Brenton at Swift Calcs or contact@swiftcalcs.com. And we try to make a real effort to help our users out.
Well, I don't see any questions. Again, I just want to thank you for that great presentation. It's got my mind turning and thinking of different ways that we can use this. There's definitely a lot of different things we can do to optimize our designs using Swift Calcs. Thank you all for attending today. I hope everyone learned something new.